Hello, grade 9 students. It's another fun learning day. Welcome to another episode of our Science 9 lesson for Quarter 3, Week 2. In our past lesson, you have learned about volcanoes and how amazing they are. Today, we will discuss another interesting topic related to volcanoes. In this radio lesson, you shall be able to explain how destructive and constructive plate boundaries are involved in the volcano making process, describe the effect of high temperature on the formation of gas, describe viscosity, and determine the viscosity of some liquids. So, get your pen and paper and your weekly learning activity sheet, and together, let's learn about primary factors affecting the volcano's eruptive style.
Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone.
Volcanoes are a clear evidence of plate tectonics processes. These are common along convergent and divergent plate boundaries. They are usually found within lithospheric plates away from plate boundaries. Wherever mantle is able to melt, volcanoes may arise. The tectonic plates continuously contact each other and are moving relative to one another. The movement of faults at plate boundaries can provide a convenient pathway for magma to reach the surface. To help us understand this more, let us get to learn the three main types of plate boundary. The first one is constructive boundaries, divergent. This is where plates are moving away from each other. New crust is created between the two plates. The second one is destructive boundaries, convergent. This is where plates are moving towards each other. Old crust is either dragged down into the mantle at the subduction zone or pushed upwards to form mountain ranges. The last one is transform boundaries, conservative. This is where plates are moving past each other. Crust is neither created nor destroyed. Now, what is divergent plate boundaries? Along constructive plate boundaries, also known as divergent boundaries, tectonic plates move away from one another to produce volcanoes. Hot magma rises from the mantle at mid-ocean ridges, pushing apart. The rock is under lower pressure. This lowers the melting temperature of the rock and so it melts. Lava erupts through long cracks in the ground or fissures. Why does melting occur at divergent plate boundaries? Hot mantle rock rises where the plates are moving apart. This releases pressure on the mantle, which lowers its melting temperature. Lava erupts through long cracks in the ground or fissures. Now, how about convergent plate boundaries? Destructive or converging plates can be oceanic, continental, or one of each. If both are continental, they will smash together and form a mountain range. If at least one is oceanic, it will subduct. A subducting plate creates volcanoes. Locations with converging in which at least one plate is oceanic at the boundary have volcanoes. Why does melting occur at convergent plate boundaries? Melting at convergent plate boundaries has many causes. The subducting plate heats up as it sinks into the mantle. Also, water is mixed in with the sediments lying on top of the subducting plate. As the sediments subduct, the water rises into the overlying mantle material and lowers its melting point. This increases melting along subduction zones. Melting in the mantle above the subducting plate leads to volcanoes within an island or continental arc. Volcanoes do not typically occur at transform boundaries. One of the reasons for this is that there is little or no magma available at the plate boundary. Magma inside a volcano has high temperature. As the magma is continuously heated, it goes up. As it rises, gas bubbles are developed. The gas bubbles are trapped and expanded, causing the molten material to swell also, resulting in a gradual increase in pressure within the volcano. When the pressure exceeds the strength of the overlying rock, fracturing occurs. The resulting break leads to a further drop in confining pressure, which in turn causes even more bubbles to form. There are primary factors affecting the volcano's eruptive style. These includes the magma's temperature, its chemical composition, and the amount of dissolved gases it contains. These factors can affect the magma's viscosity in different ways. But what is viscosity? Viscosity is the property of the material's resistance to flow. It is also described as the liquid's thickness and stickiness. The more viscous and thicker the material is, the greater is its resistance to flow. For instance, syrup is more viscous than water. Let us discuss how each factor affects the viscosity of magma. First, let's look into how temperature of magma affects its viscosity. The viscosity of magma decreases with temperature. The higher the temperature of magma is, the lower is its viscosity. As lava flows, it cools and begins to harden. Its ability to flow decreases and eventually it stops. Next, let's look at how the composition of magma affects its viscosity. Magmas with high silica content are more viscous than those with low silica content. Now on your weekly learning activity sheet, try to look at the figure 1, viscosity of magma in different conditions. The magma that contains less silica is relatively fluid and travels far before solidifying. Magmas with high silica content are more viscous than those with low silica content as shown in figure 1. Lastly, the amount of gases contained in the magma affects its viscosity. Other factors being equal, gas dissolved in magma tends to increase its ability to flow. Therefore, in near-surface environments, the loss of gases makes magma more viscous, forming a dome or a columnar, as again shown in figure 1 on your page 3 of your weekly learning activity sheet. Now here's more interesting fact. Lava with less silica content has low viscosity that it can travel a great distance, forming a thin sheet. Lava with high silica content is too viscous to travel far and tends to break up as it flows. Lava with low amount of gas and high silica content is very viscous and does not flow out at all as it rises, forming a columnar plug in the vent. Lava with low amount of gas as it rises has high viscosity that it piles up at a vent, resulting in a dome, forming a columnar plug in the vent. To help us understand more our lesson for today, let's now come to our activities. Yes, I know you're waiting for this. Our activity 1 is called Volcanoes Knows No Boundaries. In this activity, you will only explain how destructive and constructive plate boundaries are involved in the volcano making process. All you need is your learning activity sheet, your pen, and your answer sheet. As you can see on the page 3 of your weekly learning activity sheet, you will just match the types of plate boundaries in column A to its description in column B. You will copy the paragraph in column B that corresponds to your answer in column A on a separate sheet of paper. Are you ready? Very good. Now let's have number 1. What do you think best describes constructive boundaries or divergent plate boundaries? You got it right. Constructive boundaries are plates that are moving away from each other. New crust is created between the two plates. Now let's try number 2, destructive boundaries. What do you think is its description? Very good. Destructive boundaries are where plates are moving towards each other. Old crust is either dragged down into the mantle at the subduction zone or pushed upwards to form mountain ranges. Now let's try number 3, transform boundaries. What description best describes transform boundaries in column B? You were again correct. Transform boundaries are where plates are moving past each other. Crust is neither created nor destroyed. This time, can you share me your idea about this question? How volcanoes are formed in a destructive and constructive plate boundaries? I'll give you time to answer. Wow! You got it correct. A volcano is formed by pressure building up below the Earth's crust. Magma forces its way through the weaknesses in the Earth's crust. When the magma emerges, it is called lava. When it cools, it solidifies into rock, or it may emerge through thin cracks, which are called fissure. Or it may be forced through wider pipes that starts to build up to a volcano. Let's now have activity 2. It is called under pressure. Exciting, right? In this activity, you will describe the effect of high temperature on the formation of gas. All you need is your learning activity sheets, your pen, and answer sheet. Now what are you going to do in this activity? You will study the simple experiment conducted by a group of grade 9 students. Then, you will answer the questions that I am going to give. Write your answers on a separate sheet of paper. Are you ready? A group of grade 9 students performed a simple experiment describing the effect of high temperature to the formation of gas. The materials are the following: 2 300 ml bottled soft drinks. It must be sealed before using. 2 300 ml bottled cooking oil. 2 identical small basins and a hot water. Now what are they going to do? The procedures are: number 1, half fill basin A with hot water and basin B with cold water. Second, put 1 bottled soda in basin A and another one in basin B. Wait for 3 minutes. Number 3, slowly unscrew the caps from the bottle in each basin and observe. Now their observations are: a fizzing sound was heard, followed by the rushing out of bubbles from the bottle dipped in hot water. There was also a sound heard in the bottle placed in cold water, but not as much as in bottle A. Now let's try to check how well do you know, do you observed, and do you learn in our activity. Number 1. How will you explain your observations for the said activity? Yes, you're right. There was accumulated gas inside the bottle. Now, what is the role of hot water in the setup of the grade 9 students' activity? Very good. The hot water increases the temperature of the soda drink inside the bottle. As the temperature increases, more gas is accumulated inside the bottle. This causes the fizzing sound. What if we use another liquid such as oil instead of soft drinks? Will we have the same observation? Replace the hot water in basin A. Put one of the bottled cooking oil in hot water and the other one in cold water. And again, wait for 3 minutes. Then, slowly unscrew the caps and observe. The observation in the bottle of cooking oil is not the same as in the soda drinks. Now, can you explain the observation of the grade 9 students' experiment? There was not much gas released in the bottle cooking oil because of its composition. Soda drink is carbonated. The high temperature released the gas from the soda drinks. Wonderful! And so that's it. We are done for today. We learned about primary factors affecting the volcano's eruptive style. And I know that you can now explain how destructive and constructive plate boundaries are involved in the volcano making process. You can now describe the effect of high temperature on the formation of gas. You can also describe viscosity and determine the viscosity of some liquids. Very good! Thank you for listening. Until next time, this is Teacher Young. Don't forget to always be cheerful and strive to be happy. Keep safe, my grade 9 students.